Okay, we're going to go ahead and get started with our webinar on audio and noise dosimetry. Welcome. I do want to let all of you know that we will have you on mute until the end of the session when we'll open up the floor for any questions or comments. At that point, unless you put yourself on mute, we will be able to hear you, and you're welcome to ask any questions that you might have. I'd like to start by introducing myself. My name is Carol Case. I'm a technical specialist at MTS Systems Sector. In case you don't know, Larson Davis has been a part of MTS Systems Sector since 2016. And I've been with the company for 2.5 years now. I have a Bachelor of Science in Mechanical Engineering from the University of Cincinnati. So what are we going to talk about today? I'm going to start by going over a little bit about the different occupational noise standards. I'm going to talk about why would you want to use audio in noise dose measurements. I'll discuss actually how to make those recordings with the Larson Davis Spartan dosimeter, and how to listen to recordings. Once you've listened to the recordings, if you find out that some of your data is irrelevant, how you might want to exclude that, and how other ways to use the data or what to do next. So first, noise dose standards. The most important thing to know is that there are a number of different standards. Lots of different agencies have weighed in on what the limits of noise that a worker should be exposed to during the day actually should be. There's definitely not agreement between the different agencies and the different standards. So you should pay attention to which standard you need to comply with. In the United States, there are 2 different OSHA standards. There's also the National Institute for Occupational Safety and Health, or NIOSH. They've weighed in with different and stricter standards. And then there are international directives and regulations as well. This all sounds kind of confusing, but the good news is that the newly released Spartan Model 730 wireless dosimeter actually allows you to run 4 virtual dosimeters concurrently. Each one of them can be set up to show data in relation to a different standard. So if you need to comply with any of these listed standards or directives, the Spartan can easily be set up to make measurements as the first step in that process of compliance. I am going to include some links to resources at the end of the webinar so that you can further explore the topic of noise dose standards. So you might want to get ready to snap a photo or take a screenshot at the end of the webinar. But right now, I'll just give you a couple of examples to help you get started thinking about how this works. Noise dose standards will typically specify a maximum time-weighted average noise level that a worker can be exposed to over an 8-hour day. So if you look at the OSHA permissible exposure limit, for example, if I were exposed to a constant noise of 90 decibels for 8 hours straight, or a fluctuating noise level that averaged 90 decibels, I would reach my limit. That math of averaging is pretty complicated, but you don't have to worry about that because the Spartan does all the math for you and just presents a percent of the limit that you've reached. So every standard also defines an exchange rate in decibels. So what is the exchange rate? Well, for the OSHA PEL standard, the exchange rate is 5 decibels, and that means for every 5 decibel increase in the noise level, the so-called perceived loudness of the noise doubles, and your allowable exposure time is halved. That being only 5 decibels might surprise you, but remember that decibels are on a logarithmic scale, so that's why there's that significance of a difference with a 5 decibel change in noise level. OSHA actually now requires companies to implement a hearing conservation program if workers are exposed to a time-weighted average noise level of 85 decibels. So there's also a built-in setting for that OSHA hearing conservation standard. And again, on that one, the exchange rate is 5 decibels. So the thing about the exchange rate is it actually varies from standard to standard. NIOSH has a stricter standard of 85 decibels for 8 hours with a 3 decibel exchange rate. Okay, so that means that every increase of noise level by only 3 decibels represents a perceived doubling of the amount of noise, and therefore halves the recommended exposure time. And then you can see that in the EU directive, the exposure limit is 87 decibels and a 3 decibel exchange rate. They also have action values that are slightly lower, and you can find more information about that in some of the resources at the end of the webinar. Okay, why would I even want to record audio in the first place with my noise dose measurements? You can see a picture here of one of my intrusive noise sources, who we will talk about more later in the webinar. There are people who actually still make observed noise dose measurements, actually watching workers as they're measuring the noise of each task completed for the day. The observer would make notes about abnormal sounds, what they were, when they occurred, so that later they could correlate that information with the data. Using audio recordings can take the place of actually observing the measurement all day long. So the audio recordings are sort of a way of automatically annotating the data when loud sounds occur. So we know that loud noises are the noises that are damaging to hearing. So it makes sense that if you're responsible for protecting workers from loud noises, from hearing loss, you're more interested in understanding what the loud sounds were that occurred during the day. If you're using a dosimeter that only has logging, what the person making the measurement actually sees at the end of the day is just a graph showing it was loud at certain times. Unless the measurement is directly observed or there's a high understanding of the work environment, you might not be able to figure out what was the cause or the source of the loud noises. But of course, if there's a sound recording, you could go back, listen to that recording, and identify the source of the noise. So why do we want to identify noise source? Well, we might be detecting tampering with the device itself, either the worker, it's very common to snap or clap or just, hey, is this thing still working? You might want to identify what is my most problematic piece of machinery or my most problematic process. You might go back and listen and find out that you have a rare or unusual noise source that's not likely to be repeated. If it's not a source that's going to happen all the time, then you don't need to be worried about it. So Larson Davis's new wireless noise dosimeter, the Spartan Model 730, allows users to record the time history of noise levels through the workday, and then optional features allow it to automatically record audio when the sound level is over a certain threshold. So for example, every time the noise level goes over 85 decibels, the device would record a snippet of the noise. Then there is the other optional feature, which is octave filters, and that allows users to see the overall noise levels from the day's measurement in different frequency ranges. So I wanted to show a real-world example of using sound in dosimetry. My job is writing about sound and vibration monitoring solutions, and fortunately that's pretty quiet. So I took a Spartan Model 730 dosimeter home to measure the noise dose of a day of housework and yard work around the house. I thought things like mowing the lawn, vacuuming and cleaning my carpet, even maybe using the stand mixer in my house might be noisy enough to damage hearing if I was doing loud things all day long. And I wanted to know which of the things I do during the day would be most damaging. So as I said before, the sound recording is an optional feature of the Spartan, and it's controlled by setting it up in the sound recording section of either the G4 Larson Davis utility software or the Larson Davis Atlas app. So you can actually set it up from either one of those. So to turn on event recording in the app, and it works in a similar way in the software, you want to scroll to event sound recording, and you just need to slide the toggle over so that enable is on. So I want to talk about how the recordings are actually initiated or how the meter decides to make a recording. When you're setting up the meter, you select a trigger source and a trigger level. So all this means is that the recording will begin automatically when the chosen metric or the trigger source gets louder than a certain decibel level. And that decibel level is called the trigger level. So in the graph that you can see on the screen right now, the red line represents the trigger level, and then there's a sound recording indicated by the small blue marks at the top of the screen. Every time the level goes above what I've designated as the trigger level. So normally people will just choose to trigger with the sound level, the decibel level with an A frequency weighting and a slow time weighting. It's the default, it's the level referenced by many of the standards and requirements you'll run across. The Spartan does give you the flexibility to choose other trigger options if they're needed. So I've just gone with the default here. And then you want to think about your trigger level. So again, this means that the meter will start recording when the sound exceeds whatever decibel level you choose. So here you can see I've chosen 85 decibels. How did I decide what to set that to? Well, if I'm interested, for instance, in complying with the OSHA hearing conservation standard, I really care most about any noises that are over 85 decibels. So that's what I'm going to use as my trigger level. And then finally, there's an option here called minimum interval, and that one might be a little bit confusing, so I want to talk about it for just a second. Audio recording on the Spartan when the recording begins, it's going to last 12 seconds. It's actually 2 seconds of recording before the trigger level is reached, and then 10 seconds beyond after it's triggered. And then, once it's made that recording, the Spartan will wait the user-defined minimum number of seconds before it begins another one. So this is to cut down on the number of recordings if the sound level is over the trigger level for a long time. So the number of seconds that the meter is waiting to begin a new recording, that's called the minimum interval, and you can set that on the screen. And then you just make sure to save the settings. And then one last thing about setting up, to see the graphs of the decibel levels over time and be able to play the sound recordings from those graphs, you want to be sure that time history is turned on. And if you want to include octave band data in your final report, make sure that that's on as well. And again, those are both optional features. Finally, don't forget that all setup, monitoring, and results reporting can be done from a mobile device, but if it works better for you, the Larson Davis utility software G4 is available, and it allows you to interact with the Spartan wirelessly from any computer with Bluetooth Low Energy. And that setup works just the same way it does on the mobile device. Okay, so after I set up the dosimeter from my phone, I calibrated the device, snapped it onto my shirt at my shoulder, and then just started to make the measurement and went about my day. When I finished with the measurement, the results were wirelessly downloaded to both my phone and my laptop. So if this reminder to calibrate has you scratching your head, you can actually check out another video that Larson Davis has made that talks all about field calibration before and after a measurement. It's available on Larson Davis's YouTube channel. It was made about sound level meters, but the same concepts apply for the dosimeter. Okay, so now we're getting down to the results. What you're looking at on the screen right now is just a view of the graph of the overall measurement from the entire day, and this came from my phone. I want to mention that the red line right here in my results is called the limit level. It's just a user-definable value that's there to give you a visual point of reference in your results. By default, it's sitting at 100 decibels. Some of the time when I was looking at data, I reset that level to 85 decibels, so you might see it at different spots in my various screenshots. But again, that's not actual data. It just allows you to have a visual reference point wherever you want it. So you can see that there were a couple of times during the day where it was consistently loud, a few times even when the noise levels reached over 100 decibels. And since I was both the person being measured and the person analyzing the results, I happen to know that the first area of loudness is vacuuming and carpet cleaning, and then the end of the day was when I was mowing the lawn. It turned out that the mixer wasn't as loud as I expected, and it actually was a very short period of time. That didn't contribute significantly to my results. But what if I didn't know what the worker was doing all day long? So that's where the sound recordings come in. So I want to show you how to take a listen to some sounds and see how that works. There are a number of ways to listen from your results, but one of the simplest is to do so right from the time history graph. This can be accomplished from your phone with the Atlas app or from the G4 software. So now this screenshot is from the G4 software. It was easier to capture video from there, so that's what I wound up doing, but it also works the same way from the phone. So here I'm looking at the overall graph of the measurement. I do want to note the areas in red and the vertical lines were excluded automatically because the dosimeter detected it was bumped. A bump often causes a noise that's really loud right at the microphone, but doesn't actually affect the user. It isn't representative data, so it's just automatically excluded. My colleague, Danielle Smith, presented a webinar about this topic last week, so if you missed that, you can also find that one on the Larson Davis YouTube channel. But back to my sound recording. So I can see these periods of time that most contributed to overall noise. I'm going to zoom in and listen to understand more about what was going on when the noise level was high. So here I'm showing how I can click on zoom and zoom in. I'll move my cursor to the beginning of one of the sound measurements and press play. So that might be a little bit difficult to hear, but even if I don't actually know what exactly is happening at that time, I'm familiar enough with what goes on in my household to know that that sound was the carpet cleaner. Next, I want to listen to a sound that was a little bit shorter but reached a higher decibel level. So again, I'll zoom in and go to the beginning of one of those blue ticks. So I don't know if you could hear that, but that was my dog howling, and unfortunately that's a pretty typical sound at my house, especially when a squirrel is at the bird feeder. So that was one that I heard quite a few times during the measurement. You can see on my phone screen here, I zoomed in to a section of my data, and the display looks very similar. The audio icon is pale when I'm not in a portion of the graph that has the sound recording. If I click onto a portion with the sound recording, it highlights, and then it turns green while I'm playing the recording. And so yet one more way to listen is to go over to the Data tab and look under the session logs. You can see I have a list of each sound recording, and this is where I could go if I wanted to download the recording as a WAV file onto my computer. So I'm going to play one last video that demonstrates playing a sound recording, and in this one you can see an example of what sometimes happens when we're looking at very short windows of time. Spartan's timestamp is with 1 second precision. So audio samples are stamped with the actual time the recording began. So sometimes it can result in a slight mismatch on the graph. The audio peak can occur up to 1 second after the peak on the decibel level graph. So this is especially common with an impulsive noise like a hand clap or a snap. Just like everybody else, when I put the dosimeter on, I couldn't resist snapping my fingers near the mic to see what would happen and if it would register the result. So let me play this video. So you can see here's the recording, there's the peak, and there was the snap. So there's a slight mismatch between the peak of the event on the graph and the sound recording. It's a small difference, but it might cause a little bit of confusion, so I did want to point that out. So let's look how to exclude data from our results. Back to my finger snap. That event isn't representative of a typical day. I wouldn't be doing that if I wasn't wearing a microphone. So I want to just exclude it from my data. So I simply click on the exclude icon, I highlight it, and you can see I just click exclude data and it turns pink to show that it's been excluded. Now it doesn't only show within the data, or the graph, it also shows in the data. So the top part of my data remains the same, the original data is still there, but I can scroll down to the bottom and see that it has updated the section called modified results. There wasn't much difference because it was a very short period of time and it wasn't all that loud, but still it's preserving the original results and then also giving me modified results. So one nice thing that this allows you to do is perform a what-if type analysis. What if I removed a particular task from a worker's routine? Maybe I assign that job to another worker who is currently experiencing a much lower noise dose during their day of work. So this is known as an administrative control. I can actually exclude an entire task on my graph, such as maybe the vacuuming, and see what that does to my data. If it makes a significant difference, I might even decide to assign a different worker to that task. I might ask one of my kids to do the vacuuming instead of me, or possibly I buy a robotic vacuum so that the vacuuming can get done when I'm off writing about noise dosimeters, and I don't have to be exposed to the noise or hassle of vacuuming anymore. So that brings me to my results, or what I learned about my day of work and my noise exposure. So I set up the noise dosimeter to show the results based on 3 different noise standards. The dosimeter, like I said before, can show the data in 4 different ways or on 4 virtual dosimeters. I'm not sure what led me to use just 3 of them, but once I was done, I wasn't going to go back and vacuum all day long again, so to get that 4th column of data. So the first standard that I looked at was OSHA's PEL. You can see that over the roughly 7 hours I was wearing the dosimeter, I only reached 2.1% of my permissible exposure limit according to the standard. The projected exposure, if I had have done similar work for the full 8-hour day, is 2.3% of the limit. Moving on to the OSHA hearing conservation limit, I reached 37.8% of that allowable noise dose, and my projected noise dose for the day was 42.3%. Finally, the little bit more strict NIOSH standard with the lower exchange rate, I was at 50.1% of the limit, or a projected 56% for my full day. So the first thing that comes to mind when I think about this data is that there's a very wide range of what's considered acceptable when it comes to allowable noise exposure. So again, it's important to know which standard you need to comply with. Even at the more strict limits, I was surprised I didn't get closer to the limits. I've always thought of both the mower and the carpet cleaner as very loud devices. So knowing that my noise dose for the day was at worst 50% of allowable limits was surprising to me. Seeing these results really gave me a better understanding of the experience of people working in noisy environments. So I do want to talk for just a second about octave bands. This is the octave band results from my data. The most common reason to look at octave band results in worker noise dose measurements is to determine the correct hearing protection. So if you're getting close to their allowable noise dose, you might want a worker to wear hearing protection. So you want to take a look at your octave band frequency analysis measurements of the noise and compare those with the published specifications for any hearing protection that you're considering. So in other words, if your noise dose is much louder in a particular frequency range, you definitely want to make sure that your noise protection that you're choosing is effective in that range. And people consider this a much better method of choosing hearing protection than the traditional noise reduction rating method. So once you've gathered all your data, what do you want to do next? If you have a situation where you're getting close to or exceeding exposure limits, you definitely need to develop a mitigation plan. You might put in place engineering controls. So that's making physical changes to your equipment, modifying a machine, replacing a machine, isolating it behind a sound barrier, in my case, buying a robot vacuum. You might need to make administrative controls, which was rotating workers so that employees are maybe doing quieter tasks for part of the day. Again, in my example, that's asking my kids to mow or take one of the jobs. And finally, you might need to require personal protective equipment, such as earplugs. You'll definitely want to continue measuring noise dose on a regular basis to see if any changes that you've made have made a difference. And then you may even need to offer annual hearing exams for your workers. So there's a lot of great information out there on both the topics of the noise regulations and the content of the noise regulations, and then also on how to develop mitigation plans. I invite you to check some of these resources out for much more detailed information. You could begin that by just searching for one of the terms that you see on the top of the screen. So if you'd like to take a screenshot now, I'm going to move on to page 2 of just a few more. And if you miss those, we will be publishing this webinar on YouTube within the next week, so you can always find these sources there as well. The last thing I wanted to say about my results is you do sometimes find out surprising or unexpected things when you make noise measurements. I actually did not play the audio recordings from the loudest measurements from my day, much to my embarrassment. Those events that measured over 100 decibels, they were all me. Yelling up to a kid in an upstairs bedroom was the loudest thing I experienced all day. So sometimes you're surprised by your results, and I certainly was surprised by that. All right, well, thank you for joining. Please do contact us through one of the channels that you see on the screen.